Hi, this is a short video on our section 4 anticipated difficulties regarding the dihedral angle, and more so looking at the rebatment method. So I've created two resources. This is the first resource that is commonly used to help students identify or find the dihedral angle. So we can see that we have a pyramid shape here, a triangular base pyramid, and what we can do is we have it set up that when we're trying to find the dihedral angle, we know that we need to view an edge view. So if we wanted to find the dihedral angle between the red and the yellow surfaces here, we need to see this line here, the line of intersection, as a true length. So what that means is we need to look at that line perpendicular, so straight on at that line. So what that means is there, if we were to use this model, we can use it to normal to and look directly in at this line of intersection, and that will give us the true shape. And this is what the projection behind on the auxiliary plane shows here, our shape. So this is our true length line of intersection, which corresponds to this line here. And then what we know is that when we see the true length of a line, we must view it as a point view. So we must view this line highlighted here in blue as a point view as shown. So if we were to rotate our object around, we would view our object, our line of intersection, as a point, and this will give us our dihedral angle. So just to make it more accurate, if we look normal to this, we can see now that this is a true dihedral angle for the surface. So that is just a quick explanation there of just how we normally find the dihedral angle for students. And so we're looking at the rebatment method. We have a second model here that will just pop up in the middle, and it's just the same object again, but this time we will be using the rebatment method. So really what rebatment is just rotating an object or a line or a point or a surface to see its true shape. So as we can see here, we have the same object with our line of intersection here, just highlighted as blue there at the moment. And what we can do is, in the rebatment method, it's just a tidier, simpler version. Instead of doing one or two auxiliaries to find the dihedral angle through the point view method, whereas rebatment method is that we must view the line of intersection as perpendicular again. So if we are to look perpendicular straight onto that line of intersection between the surfaces, this gives us our true length. So when dealing with the rebatment method, to find the dihedral angle, we must project perpendicular from our line of intersection, and that line plane, cut plane or a plane surface, as we can see here, is perpendicular to the line, and where it cuts the base gives us our points on the base, and by joining these back, this will give us our dihedral angle. And similar to looking at the first question, if we were to look straight on at this angle, if we were to rotate around and view our line of intersection as a point, these lines here from this point to here and this line here is our dihedral angle, because we are looking straight down along the line to see our line of intersection as a point view. And if we were just to normal to this, that is still our same, just rotate around, but that is our dihedral angle. So in the rebatment method, all we have to do is rotate our point of intersection until it is flat on the horizontal plane, and by doing that we get the true shape of the dihedral angle in plan view. And looking down at our tab, so this is our point that is rotated until it's horizontal onto the base, and now we can see that our true angle here in plan. So that's just a quick resource that we found that might help students to visualize the rebatment method a bit easier. So it just cuts out on the extra view. We just draw one auxiliary looking straight on. We see our line of intersection as a true length. We rotate down our point down onto the horizontal plane, and then in plan we can just project and see our surfaces, and that gives us our true our dihedral angle here. Thank you.